Alright, welcome back to Math 126 video. This is a video for section 10.3 and 10.4. There was only one question asked in the discussion. Excuse me. So I'll do that one. This is kind of concerning that there's not a lot of discussion going on right now. That either means you all know what's going on or you're completely lost. If you are completely lost, get into the discussions, post questions, because if you don't, you're going to stay lost. And given the material, I find it less likely that you all know exactly what's going on, because we're in matrices now, and if this is the first time you've seen a matrix or had to deal with a matrix, it's usually not easy when you see it the first time. So anyway, here it is. It's question number 13 and 10.3 is the one that was asked. So let's take a look at it. They ask you to solve this specifically by either Gauss or Gauss-Jordan elimination, right? So that is to say, we want to turn it into a matrix first and then go through the process of eliminating and turning it into an identity matrix on the left, where we just have ones down the diagonal. So the first thing I want to do is write this as a matrix, and to do that I just use the coefficients. So there's going to be a lot of erasing in this problem. As you can see, just the problem takes up a very large portion of the board. So you might have to pause a bunch of times, but to write this as a matrix, I'm just going to take all of those coefficients. So it'll be 2, minus 1, 3, and then the augmented part over here with a 0. And a negative 2, a 1, a negative 4, 3. 1, negative 2, 4, negative 6. Right? That's where we're starting. Okay. Now, in order to go through the row operations, I want a 1. The very first thing I want to do is get a 1 right here in the upper left. And it's easy to do that because I have a 1 down here, so all I have to do is switch those two, right? This row is going to move up to the top row is going to move down to the bottom. There is a row manipulation kind of a process. Those little arrows are pretty obvious if you see them, that they're moving. But the actual written out way would be to say lowercase r for row 3. My old row 3 moves in to become capital R, which is a new row, 1. And likewise, my old row 1 moves in to be my new row 3. Right? And if I do that, I'm going to erase my top here. I end up with, I'm going to go back to blue or black. I end up with just these two switch. So 1, negative 2, 4, negative 6 moves up to the top. The middle stays the same, so I have negative 2, 1, negative 4, and 3. And then the top one moved down to the bottom, so that's 2, negative 1, 3, 0. Right. And I've got what I wanted. I got a 1 in the upper left corner. Right. The next thing I want to do is zero out everything below that 1. Right. Everything that's not that 1 in this column, I need to zero out. And I can do that, and I usually want to do that by using the 1. So again, in this notation here, I'm going to say that if I multiply the row 1 by 2, that makes a 2 here, and if I add it to the negative 2, that gives me 0. So that's what I want to do, is 2 row 1s plus row 2 become my new row 2. My row 1 I don't want to manipulate, so I can just say that it's just going to move over. But then on row 3, I want negative 2 row 1s added to row 3 to become my new row 3. Right. And I have a new equivalent system, a new matrix over here. So then row 1 didn't change. I have 1, negative 2, 4, negative 6. Row 2 does change, and how it changes, I'm going to multiply everything in row 1 by 2 and then add it back to row 2. And so I'll do that element by element. Starting at the upper left, I have a 1. Multiply it by 2 is 2, plus the negative 2 is 0, and that goes here. I have a negative 2 that gets multiplied by 2, which is negative 4. Add it to the element in row 2, so I have negative 4 plus 1 is negative 3. Right. I have a 2 times 4 is 8, plus negative 4 is 4. Okay. And then I have 2 times negative 6 is negative 12, plus 3, negative 9. Okay. Next one down here is negative 2 times row 1 added to that. So negative 2 times 1 is negative 2, plus 2 is 0. And I have the 2 zeros here that I was looking for. Negative 2 times negative 2 is positive 4, plus negative 1 is 3. Right. Negative 2 times negative 4 is, positive 8, plus 3 is 11. And then negative 2 times 3 is negative 6, plus 0 is negative 6. Okay. I did that last one wrong, I feel like. I think I multiplied row 2. So let's go back and redo that one because I feel bad about it. My apologies, but I'm pretty sure there was something wrong there. Negative 2 times the element in row 1, so negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 2 is a positive 4, minus 1 is negative 3. Or is a positive 3, my bad. Right. Negative 2 times negative 4 is negative 8, plus 3 is negative 5. So I did do something wrong on the first one. And then negative 2 times negative 6 is a positive 12, plus 0 is 12. Okay. Alright, the next thing that I want to do is get a 1 in the middle, right? And I can do that by swapping these two rows if I want. That's not going to help because the other one's not a 1. So really the only option I have here is to divide that entire second row by negative 3. Right? It's not the only option. Once you start playing with these a little bit more, you could say, well, let's come back to that and let's worry about the next step. But we're not there yet, so I'm going to have to divide row 2 by negative 1/3, or multiply it, by negative 1/3. Divide it by negative 3, multiply it by negative 1/3, same thing. The other two rows I'm going to leave alone. And so my new system is 1, negative 2, 4, negative 6 still. The bottom is the same, 0, 3, negative 5, and 12. The top is just divided by negative 3, so I get 0. Negative 3 divided by negative 3 is positive 1. That's what I want there. And then this 4 times negative 1/3 just becomes negative 4/3. So unfortunately I'm going to have to deal with fractions through the rest of this, but they're not too bad. And then negative times negative is positive. 9 over 3 becomes 3. Okay. And I've got the second 1. And of course I'm going to then use this 1 in order to eliminate everything else in that column. And I do that again by these row operations. So row 2 is the one that I'm using. It's going to stay the same through this operation. But I want to take negative 2, just 2 row 2's and add it to row 1 to become my new row 1. Because if I multiply this by 2, it's a 2. Add it to the negative 2 and it gives me 0. And that's what I'm looking for. Likewise down here I want negative 3 row 2 plus row 3 to become my new row 3. The middle one didn't change, so I'll just write that. The top one is 2 row 2's plus row 1, so 2 times 0 is 0, plus 1 is still 1. I don't ever want to mess up those 1's once I get them, and I didn't. 2 times 1 is 2, plus negative 2 is 0. That's what I was looking for in this step, is to get a 0 there. 2 times negative 4 thirds is negative 8 thirds. And I'm adding that to 4, which is the same thing as 12 thirds, right? That's 4 thirds. 2 times 3 is 6, plus negative 6 is 0. The bottom one, I'm taking negative 3 times row 2, adding it to row 3. So negative 3 times 0 is 0, plus 0 is 0. Negative 3 times 3 is negative 9, plus 1 gives me, oh, I did that backwards. Excuse me, negative 3 times 1 is negative 3, plus 3 is 0. And then negative 3 times negative 4 thirds is a positive 4, plus negative 5 is negative 1. Negative 3 times 3 is negative 9, plus 12 is negative 3. Or sorry, is positive 3. Alright, and then my next step I want to get, I've got a 1 going down the diagonals, but this bottom guy here is a negative 1, so I'm just going to multiply this bottom one by negative 1 to get that to be a positive. That gives me the system 1, 0, 4 thirds, augmented with 0, 0, 1, negative 4 thirds, and 3, and then 0, 0, that goes positive, and that goes negative. Right. My last step then is to take this 1 in the bottom right and use it to get rid of the 4 thirds in this column and the negative 4 thirds as well. So that is to say that I'm going to use negative 4 thirds row 3 and add that to row 1. That's going to be my new row 1. I'm going to take a positive 4 thirds row 3 and add that to row 2, and that's my new row 2. And then of course the bottom doesn't change. Right? So looking at the first one, 4 thirds, negative 4 thirds times 0 is 0, plus 1 is still 1. Negative 4 thirds times the other 0 is still 0, plus 0 is still 0. And then negative 4 thirds times 1 is negative 4 thirds, plus 4 thirds is 0. My second one takes 4 thirds times row 3, so 4 thirds times 0 is 0, plus 0 is 0. 4 thirds times 0 is 0, plus 1 is 1. 4 thirds times 1 is 4 thirds, plus negative 4 thirds is 0. Right? And then 4 thirds times negative 3 is negative 4, plus 3 is negative 1. And I skipped one up here. Let's go back and take care of this spot. That would be negative 4 thirds times negative 3, which gives me a positive 4, plus 0 is 4. And the bottom doesn't change. It's 0, 0, 1, negative 3, and I have a solution, right? This whole thing started as a system of equations with x, y's, and z's. X equals 4, y equals negative 1, and z equals negative 3. So that is to say I have x equals 4, y equals negative 1, and z equals negative 3. Or I have the triplicate solution of 4, negative 1, negative 3. So again, I hope that helps. It's not an easy system to learn. It's very useful, but it is a system that has some growing pains to get through it. So anyway, give it a go. It's definitely worth taking the time to work through a couple of these. And if you still don't feel comfortable with them by the end of the 10.3 homework, I can throw up some other problems in the discussions or wherever, but just let me know if you need those. Thanks, and I'll see you next time.